I just turned up first semester. Oh wow, turn up. All right, no, we're not. No one's fighting demons. We're gonna do this. All right, here we go. We have been working with differential equations for a while, guys. When you guys go to the university, there's a course called differential equations, and all that is about this. And in that class, they do higher order, second order differential equations, ROC, Laplace transforms, all that good stuff. Right here, relax. Right here, we're just working with first order and simple differential equations. We're not going to do anything fancy. And then this is your introduction. If you go into higher level math, you will. If you go into higher level math, you will see this again at a higher level. Higher level. All right. So what do we know how to do right now without any assistance? You can do example 1 without any assistance right now. You look at it, it says find all functions y that satisfy this differential equation. So here's my derivative. That's what dy dx means. And they want y. So you go, right now is what you know. You go y equals, and you say, oh, well, what's antiderivative of secant squared? 10x plus, what's antiderivative of 2x? X squared. Yeah, you can say 2x squared divided by 2. That's the same thing as x squared. What's antiderivative of 5? And then we say what else? Plus c. And those you know how to do without any assistance. And that's it. Was that simple? Yeah. Look at example 2. You can do those without much assistance because we've already done them. It says find the particular solution to the equation whose graph passes through the point 1, 0. So they want the exact equation. So here we go. I'm going to write y equals, and I do antiderivative of e to the x, which is what? E to the x. And then minus antiderivative of 6x squared, which is, yep, 2x cubed, right? If you take the derivative of that, that's 6x squared. And then I put plus what? Plus c. And now I use that coordinate. You see that 1, 0? I use that coordinate to find the c. So I put the 0 for the y. I put the 1 for the x. So e to the 1 minus 2 parentheses 1 to the third plus c. And let's see what we get. 0 equals e minus 2 plus c. And I move these two to the left. So when I do that, c equals, and I know that I'm writing c on the left-hand side, but I like to have, okay, I won't do that because some of you guys don't like it. 2 minus e equals c. No, e to the 0 is what? E to the 1 is just e, right? Yeah, that's what spring break does. That's what spring break does. It's all good. It's all good, guys. Spring break. All right, now that I know what my c value is, here's my function. Usually they write f of x, but let's see. Find a particular solution, that's fine. We'll just write y. Y equals e to the x minus 2x cubed plus 2 minus e. I like to check it. You don't have to, especially on this one, but I like to check it. When I plug in a 1 in for my equation, I better get a 0. So let's see, y of 1 equals e to the 1 minus 2 times 1 to the third plus 2 minus e. Let's see if we get 0. 2, negative 2 plus 2, do those 0 out? Yep. Look, e to the 1 is e. E minus e, do those 0 out? Yeah, it works. I know some of you are just kind of going through the motions and you're like, I don't see why I'm ever going to use this. Remember, guys, that math is just the language of the universe. This could be a model for something. Hopefully in a little bit when we start doing a whole bunch of free response questions, you'll see, look, we're going to be doing free response, like real world applications. We're going to have a wasp, we're going to have money, we're going to have temperature, we're going to have radioactive decay. Oh, that's going to be so much fun. No, because that's where the formula comes from. When you chemistry majors, you medical majors, you always use that formula for half-life, but you don't know where it comes from. We're going to derive it from scratch. Yeah. All right, here we go. Here is the new stuff. So it says separable differential equations. A different equation in the form dy dx equals fy gx is called separable. We separate the variable writing in the form 1 over f of y dy equals g of x dx. The solution is found by antidifferentiating each side with respect to its thusly isolated variable. Okay, whatever. Child, what does all that mean? All that means is x's with the x's, y's with the y's. And they give you free points in the free response when you do that. Child, I don't understand anything you're talking about right now. Okay, let's go slow. Ready? Notice that this derivative, dy dx, is in terms of x and y. Before, look at example 1 and example 2. Example 1 was always in terms of x. Example 2 was always in terms of x. So it was simple to do antiderivative. Does that make sense? Now we have x and y's. So we're going to group the x's with the x's, the y's with the y's. Cool or not cool? Okay, so look, algebra first. I haven't done anything. dy dx equals, and then I'm just using my law of exponents. You see that squared? That means x squared, y squared, law of exponents. Have I done anything you don't know? Okay, now I'm going to group the y's with the y's and the x's with the x's. So I'm going to pretend this dy dx is like a fraction, dy over dx. I'm going to go times dx, and that y squared, I'm going to divide by y squared, divide by y squared. So I have this dy y squared over y squared equals x squared dx. Is everyone okay with how I got that? Ask me questions, guys, because I can't read minds. Okay, here we go. I'm going to rewrite this. You always want to have the dy at the end, so I'm going to rewrite it like this so it's easier to see. And now what I want to do is I want to get rid of the dy and I want to get rid of the dx. I can do that if I integrate. And now it just looks like, oh, look, I just take the antiderivative of that and I'll get the dy and dx out of there. I'm going to rewrite it so it's easier. Here I am. I'm just rewriting it, guys. I haven't done anything yet. There are no limits. So you can, if you want, put plus c on both of them, but I'm going to let them be absorbed into one, and I like to write the c with the x's. Chav, what are you talking about? Like this. Don't write this down. Just listen, because I don't want you to write this initial stuff down. If I did it, I could do this. I can go antiderivative of this. Don't write this down. I'm going to give you guys a chance to write down. Antiderivative is y to negative 1 divided by negative 1. So it's this. And then I can write plus c. I'm going to write 1. Don't write this down, guys. Equals x cubed over 3 plus c2. Do you guys see that? And then I can go like minus c1, minus c1. And c2 minus c1, isn't that just still some constant? And then I would write something like this. And then I would write plus c3. It's just some constant. But why do I want to have all those c's? It just makes it complicated. So notice how you just have one c there. So here's how I like to do it. So hopefully you didn't write any of that down. We can do this together. So watch. We can just do this. Okay. Follow with me. Now you can write down. Ready? Antiderivative of y to the negative 2 dy. That's just a negative 1 over y. And you can write plus c if you want, but I'm going to absorb them all into 1. So I'm just going to write it for the x. Equals, what's antiderivative of x squared? S cubed over 3, and then I put plus c. That c has the c from the other side as well. Does that make sense? Okay. What's up, Delgado? Tell me. We're good? Okay. This seems like a good location to solve for my c value. We let the condition dictate, and we're going to solve for that c. Are we okay? All right. Look, they're making it simple. X is 1, y is 1. They're both 1. I know I said x when I was underlining y. My bad. So negative 1 divided by 1 is negative 1 equals 1 to the third power is still 1. So that's going to be 1/3 plus c. How do I get c? Minus 1/3. So what is c? Negative 4/3. I come back to where I was. And here we go. I'm going to write negative 1 over y equals x cubed over 3 minus 4 over 3. Are we still okay? I notice a common denominator. Let's use our algebra skills. Try to write small because try to write small. X cubed minus 4 over 3. Can I do that? Okay, so catch up to there. I notice I have a negative 1 in the top over y. Look, I have a ratio on the left and a ratio on the right, and there's an equal sign in the middle. So can I flip everything? Yeah, they're still equivalent. Y over negative 1 equals 3 over x cubed minus 4. Can I do that?
Why would you do that? So
it's because I'm trying to solve for y. You know what I mean? I'm trying to solve for... You could have also cross-multiplied. Yeah, you could have also cross-multiplied. You guys like that better? Oh, yes. I would have done... if I were really doing this on my own, I would have just done negative y equals that and then move the negative to the top of the 3 there. That makes sense? So I'm just going to say... Do I have room anywhere? Let me put the arrows. Sorry for all the arrows. Here you go. negative y equals 3 over x cubed minus 4. And then I'm just going to move the negative to the top there. So that means y equals negative 3 over x cubed minus 4. There is my function. How do we feel? That's about as hard as it gets. It's not going to really get harder than that. Yeah, we'll do a whole bunch of problems. Oh, sorry, because you're the one, you said, I don't know.
Oh, I was thinking about that.
Oh, okay.
It wasn't me.
You can see, here's that quiz 34 that I was telling you about to put in your calendars. You have a whole week and an extra day. These aren't all of them, but there's 3 of them right off the bat from that quiz. And it says, use integration to find the general solution to the differential equations. So I know that it just has x's there, but let's get in the habit of separating the variables. So before you do anything, do this. So dy dx equals 4x squared minus 4x. And then let's get in the habit of going times dx. dy equals 4x squared minus 4x dx. And I put, you don't have to put parentheses on the 4x squared minus 4x, but, it's a good habit. It's that times dx. And then how do I get rid of the dy? By doing a what? Integral. Integral of 1 dy is literally just y, right? Because it's the antiderivative of 1 with respect to y. Equals, what's the antiderivative of 4x squared? 4. Perfect. Yeah, you can say 4/3 x cubed. I write 4x cubed over 3. No big deal. Minus what's the antiderivative of 4x? 2x squared. And then put a what? Plus c. Always have a plus c. Which one has that? Is it letter A? There it is. Are we okay? All right, let's go to the next one. The next one does have x's and y's. X's with the x's, y's with the y's. Leave this numerator together, leave that denominator together. So times the denominator, so here's what I'm going to have. Y plus 5, put the dy at the end. I know some of you write dy, y plus 5. No, dy at the end. Equals, parenthesis, x minus 3, close it, dx. We got the dy at the end, right, Ms. Flores? Oh, okay, sorry. Let's check it. Hey, no, we're good, guys. We're all family here. All right, here we go. Integrate. What's antiderivative of y? Y squared over 2. Plus, what's antiderivative of 5 with respect to y? 5y. Equals, what's antiderivative of x? Minus, what's antiderivative of 3? Plus c. Let's see, what am I going to do? Okay, notice, look at all the answer choices. See how they all equal C? Move everything to the left. So I'm going to have, let's see, and then we'll see. I'll talk to you about it in a little bit when we get there. Negative x squared over 2 plus y squared over 2 plus 3x plus 5y equals C. Chubb, I don't see that answer in there. Multiply everything by 2. So let's see. If I multiply everything by 2, now I'll leave the color over here. Negative x squared plus y squared plus 6x plus 10y equals C. Chubb, how come you didn't write 2C? A constant times 2, is it still a constant? Yeah. So leave it alone. Leave it as C. So now let's look for that. Is that in there? It's letter C.
Do you multiply by 2 because you don't want the x's and y's to be a fraction?
Yes. I didn't see any fractions on A, B, C, D, E. So I multiplied by 2 to get rid of that ugly 2 in the denominator. By the way, guys, if I would have seen, they would never have both of these answers here. But if you would have seen this, if you would have seen x squared minus y squared minus 6x minus 10y. They would never have both of these in here. But if you had that one in there, that one would have been correct also. Because that's like multiplying everything by a negative 2. And remember, a constant times a negative number, is it still a constant? Yes. So it still would have been a correct answer. Cool or not cool, guys? All right. Here we go. Next one, example 6. All right. So I see a secant y there, and I see. All right. So here we go. Divide. So I see. Here's what I see. dy over secant y equals 1 over x minus 3 squared dx. Oh, I don't know antiderivative of secant y. Slow down. 1 divided by secant, or 1 over secant y, is the same thing as, you guys all took pre-cal. Yeah, 1 over secant y is the same thing as cosine y. So I can rewrite this as cosine y dy equals 1 over x minus 3, put a square on that, dx. Are we okay? I hope, and it's okay if we're not, but I hope we're in the level where you do not need to do u sub on the right-hand side. If you feel compelled, go ahead, but you don't need it. Integral. What's antiderivative of cosine y? Yeah, sine y. Equals antiderivative of 1 over x minus 3 with a square on it is going to be a negative 1 over x minus 3 plus c. Chav, I don't know how you did that so quick. If you wanted to, you could have done u equals x minus 3, du equals dx, and then you would have seen this as 1 over u squared integral du, and then you would have said, well, that's u to the negative 2. Add 1, u to the negative 1, divide by negative 1, 1 over u plus c. And there's my u, x minus 3. Do you guys see that? Okay. You don't have to. I want you guys to have done so many. By now, you should have already done like 100, 200 integrals by hand. So by now, you already see. This is why I tell you guys: try not to use the calculator. Try to sweat. If you sweat, like that's okay. And I'll stop because I can go off on a tangent. Guys, by now, you guys know. You guys have all lived life, 17 years, 18 years. You know that how do you get better at anything? With experience. Practice, experience. That's experience. You know, so that's why old people tend to be super smart, because they just have a lot of experience. That's all. Anyways, what's the answer for this? Is it B? Yeah. Right. And as you can tell by the font, thank you, Delta. Yeah. I did not bother change. If I have a lot of time, I go ahead and change the font, but I did not bother. I'm just going to copy paste. So here are some examples. It says, given the differential equation, blah, 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 find a particular solution with the initial condition f of 4 equals 2. If it helps, you can write this as an ordered pair, 4, 2. And here we go. You guys ready? So let's practice. So I'm going to have dy dx equals 2x minus 5 over y times y times dx. Y dy equals 2x minus 5 dx. Are we still okay, guys? Integrate. Yeah, I can tell some of you guys didn't sleep early. You're still with spring break. Try to get some sleep tonight, guys, because we're going to hit it pretty hard tomorrow. Antiderivative of y equals antiderivative of 2x minus antiderivative of 5 plus c. You can actually, if you want, you can get it down to y equals and then solve for c later. But I kind of feel like once I get it to here, it depends on you. I just think it's easier. Well, I already have an expression. Might as well just put 4, 2 and see what I get. Does that make sense to you guys? So I'm going to plug in 4, 2 and see what I get for c. So 2 is a y value. So 2 squared over 2 equals 4 squared minus 5 times 4 plus c. And let's see what I get. I'm going to put the arrow over here. 2 squared is 4. 4 divided by 2 is 2. So 2 equals 4 squared is 16 minus 5 times 4 is 20 plus c. So 2 equals negative 4 plus c. So let's see. Plus 4 plus 4. 6 equals c. Now that I know that 6 is c, I come back to this spot, the original where I left off at, and I write y squared over 2 equals x squared minus 5x plus 6. Are we okay? Okay, now I'm solving for y because they want the original equation. It says find f of x. So times 2 everything. So I'm going to go times 2. Whatever you do to one side, do to the other, times 2. So y squared equals 2x squared minus 10x plus 12. And then what do I do to get rid of that square there? Square root. Square root, square root. Y equals the square root of all that. 2x squared minus 10x plus 12. And I'm just going to write f of x. F of x equals square root 2x squared minus 10x plus 12. And then I like to check it. How do you check it? You just plug in what? Yeah, you just plug in 4, see if you get 2. So let's see. Let's check. I'm just going to put the word check here. Check. Square root 2 times 4 squared minus 10 times 4 plus 12. Let's see. 4 squared is 16. 16 times 2 is 32. 10 times 4 is 40. And then plus 12. So 32 minus 40, that's negative 8. Plus 12. Negative 8 plus 12, that's 4. So square root of 4. Does the square root of 4 equal 2? Yep, it works. I got the 2. So this is my function. Don't worry, guys. We're almost done. We're not going full throttle today.
A lot of us are confused about like what a negative, like a negative 5.
Negative 5 to the power of 2. Oh, well, is the negative with a parenthesis or without it?
Without, like,
It's just like this. Negative 5 to the power of 2 is negative 25. Because it's like saying y equals negative x squared. Now, remember, negative x squared looks like that. So see how all the values are below the x-axis? So it stays negative.
everyone's doing the parentheses. Some are doing the parentheses.
Yeah, if it's just negative 5 squared like that, it's it's literally saying this, the 5 that's being squared. If you have it like this, then yeah, then it is positive. Just remind them y equals negative x squared is always below the x-axis, or bring the problem to me and I can check it out real quick. But let me just finish. Come back in 20 minutes. Okay. Well, we can be fast. Come back in 15 minutes. Okay. All right, here we go. Ready, guys? It's because I don't know how, I think you guys know law of exponents, but yeah, we'll see. Let's look. Okay, what is the particular solution to the differential equation dy dx equals e to the x plus 2, and then times 2 minus y squared with initial condition. Okay, this doesn't even look that bad. I thought it was going to be bad, but it's not. All right, here we go. Y's with the y's, x's with the x's. They group them on purpose, so do not degroup them, if that makes sense. dy over, and I'm going to write 2 minus y close it squared equals e to the x plus 2 dx. I don't see any major issues. I think I'm ready. All right. Integrate. Hopefully we don't make any errors there on this one. So this is going to be, let's see, negative 1 over 2 minus y. Ooh, there's a negative y. Negative times the negative is a positive. So positive equals e to the x plus 2 plus c. Let me make sure that everything is correct. Negative 1 over u, but then times negative, so negative is positive. Yep, everything looks good to me. Are you guys okay so far? I am kind of tempted to plug in my condition already. Yeah, let's plug it in. So here it is. So I'm going to go 1 over 2 minus a negative 2 equals e to the negative 2 plus 2 plus c. Oh, thank you guys. Thank you. I appreciate you guys. Those are heavy, man. 1 over 4 equals e to the 0 plus c. What's e to the 0? 1. So 1/4 equals 1 plus c. Move the 1 to the other side. C equals, is it negative 3/4? Okay. So now I'm going back to this location. So let's see. I'm going to write it right here. 1 over 2 minus y equals e to the x plus 2 minus 3/4. Are we okay? You know what? I'm going to take a sneak peek because there's so many answers. Okay. I did that on purpose. See the bottom left-hand side? The answer is there. There is so many ways to answer this one. So many ways. They did it this way. All this is over 1. They did it like the a over... Okay, side note. A over B equals C over D is the same as saying B over A equals D over C. Yeah. That's the method they did. So I can just flip this since I have the left side as a fraction or a ratio. The right side is a ratio. Well, now it is all over 1. So I can just flip 2 minus y equals 1 over e to the x plus 2 minus 3/4. Some professors might hate that though, but that's fine. Who cares what they think? Correct math is correct math. Move the 2 to the other side. Negative y equals 1 over e x plus 2 minus 3/4 minus 2. And then divide both sides by negative 1 or multiply both sides, whatever you guys think is easier. I'm going to move the 2 to the front so it's positive so it can look like the answer choice here. 1 over e to the x plus 2 minus 3/4. Oh, well, it almost looks like it. I thought it did, but there it is. How do we feel? Yeah, it's just algebra, guys. It's just algebra. That's not the only answer. This probably has like a good 3-4 different types of ways you could show it. We graded one of these as a free response once, and there was a sheet, and it had all the possible answers, and there was like 20 of them or something like that. Yeah, wow. Like all the different, yeah, because see how you have a fraction within a fraction, and there's, yeah, then there's so many different ways. You could multiply everything by 4, 4, 4, 4, 4. Okay, all right. No, well, I mean, correct math is correct math, so no matter how you do it, it's, you know. All right, let's do this one here. These tend to be easy because now you guys know about approximation. So let's see what it says. Consider the differential equation dy dx equals x squared y squared with a particular solution y equals f of x have an initial condition of negative 3, 1. So I'm going to put negative 3, 1. Use the equation of the line tangent to the graph of f at the point negative 3, 1 in order to approximate the value of f of negative 2.8. Okay, you don't have to do any work. You're using your tangent line to find your approximation. So guys, don't be a robot. I want to give you a visual of what's happening. I'm not going to draw this situation. I don't know how the original equation looks like. It just says x squared y squared. Here's what's happening. I have a curve and I have a tangent line. If you zoom in on that tangent line enough, like let's say we zoom in right there. If you zoom in enough, doesn't that tangent and that curve look like they're almost going to be the same? And if you the approximation right at the point of tangency is perfect. But if you move a little bit away from that point of tangency, you can use the tangent line to approximate the value of that curve. It's not going to be perfect, but it's going to be pretty close. Do you remember that, guys? So, yeah, a little to the left, a little to the right. So all you're doing is finding a tangent line and using that tangent line to approximate the curve. The further away you are from the tangent line, the worse your approximation is. But, you know, negative 2.8 is pretty close to negative 3. Do you guys see that? Okay, so there it is. I know it's very easy to be a robot. Don't be a robot. Make sure that we understand what we're doing. Find a tangent line. What 2 things do I need for a tangent line? Point and slope. Do I already have a point? Can I get a slope? Yes. dy dx evaluated at negative 3, 1 equals parenthesis negative 3, close it squared, parenthesis 1 squared. Here's that situation like the lady that came in a little while ago was talking about. Negative 3 squared is 9. 9 times 1 is 9. So this is a positive 9. Are we okay? All right. That's my slope. Here's my point. Y minus 1 equals slope. X minus a negative 3, so plus 3. That's my tangent. I'm using this to approximate what value? Negative 2.8. That's what I'm going to put for X. So I'm going to write f of negative 2.8 is approximate 9 parentheses negative 2.8 plus 3, close it, plus 1, which equals, and that's okay, that's not a linkage error, because you're telling me this equals something, and that something is approximately f of negative 2.8, so this is perfectly fine. So let's see. 9, and then negative 2.8 plus 3, what's that? Negative 0.2 plus 1. And then I think we can do this without a calculator. What is 9 times negative 0.2? Is that negative 1 point?
Sorry, that was my bad.
Oh, yeah. Thank you, guys. It's going to be a positive 1.8 plus 1. So what is it? 2.8 is the approximate. What am I approximating? It doesn't even tell me what I'm approximating. Cool or not cool? All right, one more. There's the last one. Yep, the last one. Yeah, we're almost done, guys. We're almost done. The quantity of a substance can be modeled by the function h of t. I know, you haven't slept, miss. Or at least I think. I don't know. Is it? No? Okay, I'm sorry. If you want to take a break, go for it, miss. That satisfies the differential equation dh dt equals 1 over 80th h minus 160. One point in this function is, so here's a point, 1 comma 720. Based on this model, use a linear approximation to graph of h at t equals 1 to estimate the quantity of the substance at t equals 0.9. They don't tell me what this is. I don't know what's going on here. So we're just going to figure out, I have a point, I need a slope. So here we go. I'm going to plug in 720. So 1 over 80, parenthesis, 720 minus 160. That's my slope, right, guys? All right, so let's see what this is. 1 over 80, parenthesis, 720, 620, 520, and then put another 40 for 20, 40, 560. Let me know, guys, because I make mistakes all the time. Okay. How many times does 8 go into 56? 7? So 70. Or is it 7? My bad. It has been spring break. Oh. 80 goes into... 8 goes into 56 7 times, so 80 goes into 567 times. Yeah, look. 8 times 7. Yeah, it's 7. Right? Spring break. Spring break 24. Yeah, spring break 2024. All right. Y minus 720 equals 7x minus 1. So h of 0.9 is approximately 7 parenthesis 0.9 minus 1, close it, plus 720, which equals, let's see, 7.9 minus 0.9 minus 1, that's going to be a negative 0.1, plus 720. So negative 0.7 plus 720, which equals negative 7, nope, 7, spring break. 719.3 of something. Are we okay? All right, that's it, guys. If you need to take a quick break, take a quick break, but there is a delta activity, and that's it. We're done.
Dude, no, because look at this, though. This is pretty tangent. I can't even tell.